Talking about our tables, that if we have a group over here where we have only one person sitting at our table, they will very desperately really want to get everyone else to come to their table so that they can have a full table and they can look popular like this group over here, although on the right. And so on the left side we have our very reactive elements, and then as we move over, eventually we have stable elements in group 8. Now, also looking at the periodic table, other patterns is that our atomic number increases as we move across the periodic table. It's divided into 3 different groups of metal, non-metal, metalloids. We looked at patterns when we did our missing alien family, and also some other things in class. And so we're going to work on kind of identifying more of how the periodic table is arranged, why it's arranged a certain way. So this first part's a little bit of a review. So periodic table, it's arranged by the atomic number, chemical and physical properties. And so if you look, the number increases as you move to the right side, but it also increases as you move down to the left. It's divided into metals, nonmetals, and metalloids. And so on our periodic table, we already color-coded, we already organized that by changing the colors to being yellow, green, and blue for those things. So for our add-on, the elements are identified by the atomic number, which is also equal to the number of protons in the nucleus. Because remember that 8-man, A equals P equals E. The electrons are arranged on energy levels, which are found in the electron cloud. And so that's each of those rings. We have our electrons sitting there. Energy levels can hold 2 electrons on the first level, 8 on the second, and 8 on the third. That's like our number of chairs that we have available at the table. When we talked about reactivity, sometimes you only have 2 chairs at the table, and so once those 2 seats are filled for like helium and hydrogen, then that means that they're stable. So then you move on to the next circle, which holds 8. Once those 8 seats are filled, it becomes stable, and so on and so forth. All right, on the periodic table, we have 2 things. We have groups and we have periods. So our groups, those go up and down. So these are vertical columns with similar properties. Another name that we give groups are families. And so we call them families because they behave similarly. If you compared yourself to your parents or to your immediate siblings, your full sister, full brother type, that type thing, you share similar qualities. You probably have same hair color, same eye color, maybe the same height, similar body shape. All of that is because you are family and you share the same DNA. For elements on the periodic table, if they are in the same group, so if they're in the same column, they behave the same way because they have the same number of valence electrons. So they have the same properties. Group 1 is called the alkali metals. And so this group has 1 valence electron. These are the most reactive metals. Group 2 are the alkali earth metals. And so if you looked at your periodic table, you would see that those 2 groups are all solid blue, except for hydrogen. It has 2 valence electrons, and it is very reactive. Group 7 are halogens. They have 7 valence. Now these, an easy way to remember is that the number 7 is often like a holy number, 777, anything like that. And so for that, you're 7 there and halo here because angels wear halos. That's easy for people to remember that halogens are group 7. But these are your most reactive nonmetals. I can assure you on a test you'll be asked some question about most reactive metal, most reactive nonmetal. And so you've got to be able to distinguish between group 1 or group 7. And then group 8, those are the noble gases. They have 8 valence electrons. They're non-reactive. because their table only holds 8 seats. All 8 chairs are filled up. And so it will not react with anything around it. So those are our groups. Now, I only talked about 4 of the more popular ones, but there are 8 of them in all. Now, periods. These are horizontal rows. So horizontal is left to right. The period number equals the number of energy levels. And so that means that if you look at the periodic table randomly and you notice something is on row 5, then that means it has 5 energy levels to it. So what I need you to do at this point is that on your large periodic table in the front of your notebook, I need you to label it the same way that this periodic table here looks. So make it the same exact writings that I'm doing, add to yours as well. So I already numbered our groups up top. On your periodic table, you're going to have some numbers here, so scratch through those numbers and title this as the transition metals. Those we just kind of overlook. They don't follow the same pattern as far as the group number is the valence electron number and all that. One other thing to add is towards the top, write give and pi. So these are 2 words that we're going to use to help us remember certain qualities about the periodic table. So give stands for group number is valence electron. So what that means is that if I knew the group number, if I said that something is in group 7, I would know for sure that it has 7 valence electrons. It has 7 electrons on the outside ring of that element. And so on my picture below, these circles down at the bottom, each of those dots or line or hash marks shows a valence electron. The other word that we use is pi. So pi stands for period number is energy level. So that's kind of what I said earlier. If you know, like if I looked at this element here, it's on row 6. So I would know without having to draw it or anything, I would know already, okay, that's got 6 circles or 6 energy levels to it. So on your large periodic table, draw those circles. I'm only going to 4, but continue with the other ones up to 7. And so we kind of drew out showing our energy levels, showing our valence electrons. Let's add one more thing to this. So group 1, those are called the alkali metals. Group 2, that's our alkali earth metal. Skip over to 7, those are halogens. And then group 8 are the noble gases. They are noble because they are the only stable ones, and so they behave, they're high and mighty, and they just, behave differently.